So in section 6.1, we start to revisit how square roots work. So that should be something we've been introduced to. And then we're going to continue looking at cube roots, fourth roots, and then all the way up to possibly fifth roots and beyond. So we are going to start looking at how these roots, what they look like, and how we can start to solve them out. So in section 6.1, if we just look at an example, would be right there. So a couple things about the roots. This 4 right here, that is called your index. So your index tells you what degree of the root you are taking. So in this case, we're taking a fourth root. What we are looking for then is what number to the fourth power is going to equal back to 16. And then we're also looking at what number to the fourth power is going to equal back to x to the 20th. So that little index right there is telling us what degree of our radical we're looking at. So it's very similar to an exponent when we're dealing with the powers and such. But here we're kind of going the opposite way. Now we're kind of looking at, okay, what power do I need to raise, or what number do I need to raise to the fourth power in order to get to that 16? Now with the numbers, how we can solve this is when you go to your power sheet, and why can't I? This end of the fourth column, which it's not letting me write over here, but this end of the fourth column is all of our fourth roots. So in this column is where I'm looking to find what number is raised to the fourth power to get to this 16. Now how I read that is, in this end of the fourth column, I'm going to look for 16, which is right here. So 16 is a number that is a perfect fourth. That means that you can take the fourth root of it. And once I find my number that I'm going to try to take the fourth root of, all I do is I just slide over to this first column. That's going to be my answer. So that means that 2 times 2 times 2 times 2 is going to equal back to 16, or 2 to the fourth power is going to equal back to 16. So sometimes we're going to see numbers like 1296 or 512, and able to find those roots quickly, we can use this power sheet. That's why it can be very helpful. Now we get to the variables. So x to the 20th, I'm multiplying something together 4 times to get to x to the 20th. Well, a little trick that you can use is, really, since something times itself 4 times is going to equal up to 20, using how power rules work, when I multiply the same base powers together, I'm really just adding together their exponents. Well, I can go the other way. I can divide by the index, and that's going to tell me x to the fifth power. So when we're starting to simplify a power, whatever power I'm raised to underneath my radical, I can take that 20 divided by the index. That's going to tell me that x to the fifth is the number that I'm going to multiply 4 times to get to x to the 20th. So then to type in my final answer, I'm going to put 2, because that's what the 16 simplified to. And then I have to use this little nth root that they give me. So I'm going to do 2. Oops, nope, this one simplifies perfectly. On my bad. I'm thinking of my next section. So 2 is going to be what the 16 becomes, and then x to the fifth is what's going to happen when I take the fourth root of x to the 20th. And I'm going to hit Shift 6, x to the fifth. Now at this point, I'm going to submit it, double check my answer. Good, we got it. Now here's where we're going to want to kind of just take a peek at how they solved it. So even if you get it right, it would be a good idea just to kind of review to make sure that you are doing it correctly, not just guessing and getting it right. But then also we can see their work. So right here is where they're going to take your power of 20, divide it by 4, and then that's going to give that x to the fifth. And then this is where we used our power sheet. So we're just going to figure out what number times itself 4 times equals back to 16. So that was section 1 in a nutshell. You can use your power sheet. Just one thing to kind of help you as you do that section, if you haven't done it yet, is you will get perfect. You'll get perfect answers. So you won't get any answers that have radicals left in them. But in section 2, that's where we start to now simplify radicals where maybe we don't get a perfect nth root and we have to use some leftovers in order to simplify the radicals. So we're going to head into section 2, part 1. And move on. I'm going to find one that's just a little bit higher difficulty if I can here. Maybe not. No, it's not letting me. Anyway, so we'll head into problem section 6.2, day 1, looking at simplifying some more radicals. So this case, I kind of like this as well because this is a case where we don't have an index right here. So right here is where we're looking, okay, what root am I taking? There is no index there. Well, they didn't put anything there. What is it going to be? Well, that is just our common square root. And a square root is talking about a second degree root. So really there would be a 2 right there. They don't have to put it there, but it would be there. So that would be a square root of x to the 6th, which is going to simplify here in just a second. So if there is no index there, we do have to know that, hey, that's an index, or that's a 2 right there. That's going to be how I'm going to simplify this. So it ends up being this. I'm going to have my x from out front times x to the 6th divided by 2. And that's going to be x times x to the 3rd. And then going back to Algebra 1, if we're multiplying two powers with the same base, we are going to add our exponents. So we'll add 1 plus 3. That's going to give us x to the 4th. And we'll just double check that one. Okay, there's our result. We can see the work being shown. So when they have a square root, they're going to describe it as cut the exponent in half. You could think of it like that, or you could just say it's an index of 2, so I'm going to divide by 2. Let's look at 1. That's going to be just a little different. Just like you guys, I can't control which problems are coming up, so I want to get one that's going to be just a little bit tougher. Seems like I've frozen here. And that just kind of reminds me of, I've been getting emails. If your Delta Math is acting up, just you let me know. Sometimes you just need to maybe walk away from it so that you don't get too frustrated in things about what's happening. All right, here we go. This is what I was looking for. So now we've got a 4th root of x to the 35th. Now, based on the patterns that we've been talking about, I'm going to take x to the 35th, divide by 4. Now, what you're maybe noticing, 35 and 4, do they divide evenly? No, they're not. But I can get 35, I can get 4 to go into 35 8 times, which makes my 4th root of 32 would be x to the 8th. So 4th root of x to the 32nd would be x to the 8th. But then I'd still have 3 left over. Now those 3 x's, they're not enough. They're not a high enough power to take another 4th root. So there we have, I call it leftovers. You got some leftovers inside your radical. So we've got a 4th root of x to the 3rd left inside of there. So x to the 3rd is not enough to get another perfect 4th root out of there. So x to the 32nd, that I can 4th root out. It becomes x to the 8th. So I'm just thinking of how many times does 4 go into 32? Goes in 8 times. And then I'd still have those 3 left over. Now we're just going to double check, see if that's down there. And there it is, 8x to the 8th. And then I'd still have a 4th root x to the 3rd left. And then there's going to be my answer. So we're working on in sections 1 and 2, we're working on that idea of understanding what an index is, and then simplifying these radicals, and just kind of getting a feel for how we can take the power and we can divide it by the index, and then that's gonna be our perfect nth root, or if we have leftovers, we'll leave those underneath our radical. So you can see here, this is kind of what I was just kind of expressing in my head. I had a 32 that I could take. 32 divided by 4, I get x to the 8th. and then I'd still have those 3 left over. So you're kind of using the remainder when you're dividing to leave underneath your radical. Well, it is 10:02. So we've been on for 17 minutes. So you are free to break off if you want to work on your delta math. So please practice, practice, practice. You'll definitely see the benefits of practicing, especially now our quizzes will be on delta math. So these exact problems will be the same problems you see on your quiz. They might even be the exact same problem, depending on how it all shakes out. So you will definitely see the benefits of your practice. I'm seeing it. The people who are practicing are definitely doing much better on the tests and the quizzes. But I'll stick around if there's any other further questions on sections 1 and 2. You can let me know, and we can continue to work through some problems. Even if you have a problem on your delta math, you can let me know what it is. I can work it out, and then you can complete some of your delta math problems as well. So I'll just stay on the line. If you want to ask any more questions, you can let me know. Hey. Oh, well, it's football. It's one of those where the Vikings outplayed them the whole game, but they lost, I thought. Well, I think it was the kicker, the pass interference at the end of the half, and then just the refs in general. That was that was the difference. So they do, and then I don't know if you saw it, but Roger Goodell was at the game, and he's the commissioner, so I'm sure he's like, "Hey, we got to do anything we can to get the Buccaneers into the playoffs with Tom Brady." You know what I mean? So, but I think so. You take Dan Bailey; he missed out on 10 points. And then that pass interference was 3 points. So that's a 13-point swing. Hey, Vikings should have won by one, right? Should have been 24-23. I don't know. What's up? Hmm. Are you looking at one like I have right here? All right. Why don't you just give me your exact problem, and then Adrian will, yeah, we'll go over some of these. Okay. Yep. Yes. Gotcha. All right. So then we're gonna have this would be 5x squared with a x left underneath, right? Yeah, and then this squared goes to that x, and this is square root. All right. So one other thing from section 2 is whenever we're multiplying radicals. Now I'm only talking about these two. The only time I can multiply them is if they have the exact same index, and they don't. This one has a 4. This one has an index of a 2. So I cannot put those together. So I'm going to just have to leave those as separate entities. But I can multiply this 4x squared and 5x squared. That's going to be 20x to the fourth. And then now I'm going to have a fourth root of x squared left. Let's just see if that works. Now, delta math, it's been known to not accept certain things, and I'm I'm wondering if it is going to accept this. Um, I might need Yeah, I don't think it's going to accept this. Yeah. Yeah. You know what? I'm going to, so I don't like the way these are simplifying. This was made by Miss Schenzer. This is using some topics that we're going to talk about in section 4. So I'm going to delete this section. All right. Yeah. So we're going to see this in section 4 anyway. So what's going to happen is, so this x 2/4, because this 2 right here with an index of 4, that's going to be x 1/2. And then this is x 1/2. So really it's going to be x to the 5th, 2x to the 5th, which we haven't got to section. Oh, whoops! What did I do here now? Oh, that's right. Yeah. So you try on yours, 20 20x to the 5th. I forgot I was doing your problem. Oh, okay. Yeah, yeah. I'm gonna delete the type threes because that's gonna be something we talk about in section 4. Yeah. So this one, I already got it wrong. Yeah. We're gonna get enough practice with the other ones, so I'm gonna go back and check. I might just specially assign a couple that I know are gonna simplify correctly and be a little bit easier on you guys. So when we do assign these, there's usually about 100 problems in each section, and I usually try to look at like 10 to 12 just to kind of make sure that they're all going to be good to solve. So we don't get to see all of them. So sometimes we get some ones that don't just work out perfectly like we want. All right, let me just try another one. So Adrian, you were wondering about this one. Let's just do this next one just because here. So this first part is going to simplify to the cube root of 8 is going to be 2 cube root of x to the third. I'm going to take 3 divided by 3, which just gives me a 2x. Square root of 49 is going to be 7. Square root of x to the 10th is going to be a x to the 5th. So this one actually will work out nice. This one's going to be 14 because of the 2 and the 7. And then x to the 1st, x to the 5th will be x to the 6th. So what I was noticing as I was practicing this is look at each of your radicals, get them simplified as much as you can. And then we should be able to start to multiply out our two parts that we simplified to get our final answer. So Adrian, have you looked at your first problem on section 3? And if you want to just tell it to me, I can write it out here and we can work through it. Okay. So would you want me to keep going over any of the type 3s? How did you do on yours, Jack? Like the way I was? Okay. 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 That's interesting. Well, if you get really stuck on one, let me know. But you should only have one more to do in that section. I think there's only 2 assigned. I think most of them are going to be able to simplify like this one. So if we just kind of use our rules of what we talked about in section 6.1, then we should be able to work on those. All right, let's try another one here. Let's just see. So we got the square root of 36 x to the third. So that one I can take, and yeah, this is going to cause us to see one like Jack. So this will be a 6x and then a square root of x left underneath. Then a fourth root of 16 would be 2, and then 10 is not divisible by 4, but 8 is, so I'm going to take an x squared out because I'm going to do 8 divided by 4, which is going to leave me with a fourth root of x squared left underneath there. Okay, now let's see if this is going to accept this. So I'm going to take 6 times 2, so I can multiply 6 and 2 to make 12, x and x squared to make x to the third, and then a square root of x, and then get out of there, and then a fourth root of x squared. I don't know if it's going to accept this or not, but we'll see. So I'm guessing it's going to want us to take the square root of x, the second fourth root of x squared, and that's going to be, yeah, it's not going to accept that. Yeah, that stinks that it's doing those. I'm going to go check on that section just so others don't get super frustrated. But yeah, this should be x to the fourth. Sorry about that. I didn't realize it was throwing in those types of problems. And then it's going to walk through some ways of how to do that. So yeah, I'm gonna go look at that section again. But did you guys both completed that section already? So Adrian, I know you did. Jack, you're still working on yours? Yeah. Yeah. Mhm. Okay, let's do that one. Yeah, 4x and a quarter. Yeah, 3. Oh yeah, 5. Yeah. So then it'd be 5x to the 10/3, right? So then here we'd have to do a common denominator between these, which would be 12ths. So then this would be, let's just get the number part. So that number part is going to be 20. Now that would be 3/12ths plus 40/12ths. 43/12ths. And you should be able to do 20x and then 43/12ths. It was wrong. Okay. Well, I'm gonna go into your delta math. I'll just give you credit for that one. And then if you want to practice more beyond that, you can. But I'm gonna see if I can I think I can go change the types that you get so you don't get those weird ones like the 43/12. So sorry about that. But I'm gonna go investigate, see if I can get that changed. Alrighty. You guys have any? Yeah, so I'll give you 2 out of 2 on that section. Yep.